Okay, so what we're going to do today is we're going to go over the quiz. I tried to tell you on Friday, don't stress over the score that you see because 17 and 18 were extra credit. I knew I was planning on giving extra credit for those, but if I don't tell you it's extra credit, you guys tend to work a little bit harder at them, okay? So I just told you 17 and 18 were really tough. They're challenge problems, do your best. And on the order of operation problems or even the writing expressions, if you got part of the problem right, I gave you partial credit, okay? And online it marks it right or it marks it wrong. So we're going to go over the quiz today. We're going to go over 17 and 18 because even though they're challenge problems, you guys are capable of doing them once I show you a few examples. So guess where you're going to see problems like 17 and 18? Not possibly IA. If there was a coordinate plane problem on the IAR test, it would probably be one like 17 and 18. Aubrey, what's your guess? Yeah, it's going to be one of your weekly IXL skills when we get back from break, okay? Because they are challenging because they're more than one step. But once you see us, once we work a few together, you'll be like, oh, okay, I got it. It's really not that hard. You just haven't seen it. You haven't been exposed to it. So we're going to do some like 17 and 18. We're going to talk about all of them, okay? So we're going to go over the quiz first, and then there's some on the weekly worksheet that I told you we were going to do some examples on, some new stuff. Let's see here. I need this. And Jackson, you didn't give me, I need this paper from you eventually, okay? To give you your score, because it's not what you saw on the computer. So you can still write down, like get out a pen and you can write new stuff in a pen. Okay, number 1. What was the correct answer to number 1, Fisher? Actually, everybody go ahead and get out a pen because you're going to do some corrections while we're working. There's some stuff I corrected for you. What was the correct answer, Fisher? 51. If you missed that, write in the correct answer. The original problem had multiplication and addition. In the order of operations, what do we do first? Aiden, multiplication or addition? Multiplication. What is 6 times 8? 48. Most people, if they missed this, they took 6 times 8 and got something other than 48. But 6 times 8 is 48. And then we would have to add 3 to get 51. Questions on that one? Number 2. What would we do first, Addie?
7 times 10.
Okay, what's 7 times 10?
70.
Okay, other Addie, what would we do next?
6 times 4.
Which is?
24.
And then what would we do last, Gabe? Add them together, so we would get 70 plus 24 is 94. So the answer to number 2 was 94. Number 3, who got the right answer to number 3? Elia, what'd you come up with? 45. Let's look at it. This one I'm going to write out. So if you missed this one, I want you to flip your paper over to the back. This one, there were lots of places where students messed up. So if you got something besides 45, flip it over to the back and we're going to work it out together. I'm going to go ahead and write my PEMDAS out here to the side just as a reminder. What am I going to do first, Kinley? You didn't get, is it on the desk next to you? Okay. What am I going to do first, Braylon?
We're going to do
7 times 6, because we don't have any parentheses, we don't have any exponents, so we're doing multiplication and division. Now, lots of people got 7 times 6 wrong. They knew they were supposed to do 7 times 6, but we got all kinds of different answers. 7 times 6 is 42. Okay, now, in our order of operations, are we done with all multiplication and division?
No.
So Emma K, what am I going to do next? Yes, 4 divided by 4 because it's multiplication or division from left to right. So that's 1. And I copy down everything else exactly the same. Now I'm done with multiplication and division. I'm ready for addition and subtraction from what to what? Left to right. So we start on the left. 42 plus 4 is 46. Minus 1 is 45. So that one was a tricky one. But again, we just have to follow our order of operations. Questions on that one? Nope. This one, if people missed it, I had lots of people make goofy errors on this one. This one was 75. 75, because you would have taken 7 times 5. What's 7 times 5, Hutley? 35, and 10 times 4? 40. 35 plus 40 is 75. Okay, most people knew the process on that one. They just messed up on their math. They goofed up on their math, but that one was 75. Who has the final correct answer to this one? Elise, what'd you come up with? 48? 28? Okay, so if you missed this one, I want you to write down the correct answer is 28 and then flip it over to the back. What do you think people goofed up on this one, Bryson? 5 to the second power is telling me to do what? 5 times 5. I think I even had one person write out 5 times 5 is 10. Because they knew 5 squared was 5 times 5, but their brain saw 5 and 2 and knew it was multiplication. I don't know if it was this class or the other. I can't remember. Okay? But what is 5 squared's value, Lainey? 25. Now we have addition and subtraction. What's my rule for addition and subtraction, Carter? From left to right. So we're going to do 25 plus 5, which is 30, minus 2, and there is our 28. Questions on that one? Okay, number 6. This one was very similar, so if they missed the last one, they probably missed this one too. McKay, what's the correct answer? 40. Okay, so our answer is 40. If you missed it, write it in. Let's work it out on back. Aubrey, help me out. What do I do? Okay, 7 squared is 7 times 7, which is? 49. Copy everything else down. Wyatt, do we do multiplication or subtraction first? Multiplication. What's 49 times 1? 49 minus 9 is 40. Questions on that one? Okay, now on the expressions, it's very important to read carefully, okay? Some of them I don't think we read carefully. Some of them we don't know what the words mean. Everybody flip your paper over to the back. Everybody flip your paper over to the back. I'm going to throw out some words and we're going to say what operation it's telling us to do, okay? If we see the word sum, here, hold on, I'm going to go on to the next question. What does the word sum tell me to do, Lainey? Add. Oops. Add. Who knows a word for subtraction? Addie J? Difference. It asks me for the difference. Means subtract. I'll abbreviate because I'm out of space. What's a word for multiply? Carter? Product is the answer to a multiplication problem. Product. And divide. Fisher, what's a word for divide? Quotient. Good job. Now, if you didn't know those 4 words, you missed some, okay? Because it didn't say then divide. It would say find the quotient of blah, 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 and blah, blah, blah. What are the 2 operations where the order matters? Elise? Subtraction and division. So anytime you are writing an expression for subtraction or division, slow down. Come up with your expression, reread the phrase, and then make sure you still agree with your answer. Because there were lots of them. If you see arrows on your quiz, you can flip it back over to the front. If you see where I drew arrows and minus half, that means you had something in the wrong order. Okay? Raise your hand if you had arrows on these problems. So there were lots of them, and maybe we just didn't know what the words meant. Okay, so that's fine. Some of them, though, I think if we would have read carefully, we would have eliminated some of those backwardsness. Okay, so this one says, write an expression for the operation described below. If you missed these ones, I do want you to write in the correct answer. You can just write it on front. There should be room. The quotient of 6 and 10. When it gives us these expressions, it's in order. So what does quotient mean, Addie B? Divide. So we have a division problem. 6 and 10. Go ahead, Addie. 6 divided by 10. Now, why do we not like that? Bryson? Yeah, 6 is smaller than 10. We can do 6 divided by 10, or you can do 6 divided by 10. We just haven't learned it yet. Okay, but it is possible. Did we have to solve these? No, they wouldn't give us these to solve yet, but they want us to know that when we see the quotient of 6 and 10, we know that that's 6 divided by 10. Now, how did they have us type it into the computer, Lainey? Like a fraction. So here, when we get to these, when we do 6 divided by 10, that's the answer to 6 divided by 10. What can I do to that fraction? Elise? Not solve it, it's a fraction. We don't solve single fractions. Aiden?
You can simplify it?
We can simplify it. What can go into 6 and 10?
2.
2. If I divide both of those by 2, I would get 3/5. When we have a problem coming up that's 6 divided by 10, we can just give the answer as 3/5. Because 6 divided by 10 is just giving us a division problem, and a fraction is a division problem. That's called fractions as division. That's chapter 8, lesson 1. What chapter are we just finishing up? Chapter 7, but we're actually going back to chapter 1. That's why I gave you your volume 1 books back, and we're going to talk about fractions and decimals and models before we jump into fractions. Okay, let's move on. Get rid of that. Number 8. The product of 6 and 10. Elia?
6 times 10.
6 times 10. Product means multiply, so you should add 6 times 10. Okay, this was a tricky one. Add 4 to 5. Be careful, and we're going to do it correctly. If you had something off here, I still gave you credit. But if you add 4 to 5, Bryson, what does that look like?
5 plus 4.
Why is it 5 plus 4 and not 4 plus 5? So, go ahead.
You're adding 4 to 5.
Yeah, it's saying add 4 to 5, not 5 to 4. So if you had 4 plus 5, I still gave it to you, that part of it. But then the next one, then divide 8 by the result. Divide 8 by the result. So I'm going to look right here. Divide 8 by the result. Carter, what does that look like?
8 divided by.
Yeah, because you're taking 8 and dividing it by the result of 5 plus 4. So that one was tricky. A lot of people put divided by 8 at the back. If it wanted us to divide by 8 at the back, it would say add 4 to 5, then divide by 8. See the difference? And I'm not denying that those aren't tricky. Got to read carefully. Anytime you see division and subtraction, just slow down because those are the tricky ones. Triple the quotient of 5 and 6. Triple the quotient of 5 and 6. Elise, what's something you know that it means? Okay, 3 times something because the word triple means you're going to multiply it by 3. So 3 times. What does the word quotient mean? Hutley?
Divide.
What's the whole thing? Not just divide. What is a quotient? Addie J, can you help? Yeah, the quotient is an answer to a division problem. So it is telling us to divide, but it's important to know that it's telling me to triple the quotient, which is an answer. So that's telling me I need what? Parentheses. So this one would be 3 times 5 sixths. The quotient of 5 and 6. Now, I had one person give me this. Why would that also work? The computer marked it wrong, but I wrote okay by it because technically that is also correct. Why, Bryson?
Because you're adding it up 3 times.
Yeah, because they took 5 divided by 6 and added it 3 times. So instead of writing times 3, they used repeated addition. Is that okay? Yeah. It's not the shortest way, but it works. So I also accepted that. Questions on that one? Addie?
Is it okay if you have 5 divided by 6 in the front?
Yeah, so on this one, I did take it whether that was in the front or the back because it doesn't matter with multiplication. The order doesn't matter with multiplication. So that one I gave it to you whether the 3 times was in the front or the back. Okay, number 11. Multiply 6 by 8. What does that look like, Gabe? Multiply 6 by 8. 6 times 8. Most people came up with that. Then subtract 3 from the result. So we're taking 3 away from the answer. Fisher, do I put 3 minus or minus 3? Minus 3. Yep, the minus 3 goes at the back here because it's saying then subtract 3 from the result. A result is an answer. Questions on that one? Okay, number 12. 4 decreased by the quotient of 9 and 7. Let's start with the quotient of 9 and 7. What does that mean? Jackson?
9 divided by 7.
9 divided by 7. Okay, and I'm going to put it in parentheses because it said the quotient. Now, the rest of it says 4 decreased by. Most of us know that decreased means subtract. So we could either do minus 4 at the back or 4 minus at the front. So 4 decreased by that answer. Aliyah? The front. So 4 minus 9 divided by 7. Does that make sense? Yep. Yep. Questions on that one? Do you guys understand why it's 4 minus that and not minus 4 at the back? Because it says 4 decreased by. So if I said Jackson's money decreased by Miss Schilling's money, you would take Jackson minus mine. Because you're decreasing the 4, not decreasing by 4. Okay, number 13. Okay, on these ones, if you missed, there were 2 points. If you missed 1 point, you got minus half. If you didn't miss any, you got minus 0. If you missed them both, you got minus 2. Why do you think if someone missed one of these, they only missed 1, not both? Hutley?
Because 5
Yep, because 5, 5 is 1. Even if we forget how to do these and do the common error of doing them backwards, we would get lucky. But 10, 3 is over 10, up 3. I did have some people miss that one. They went over or up 10 over 3 and had it up there at the top. Okay. Oh, I have to save answer, don't I, to there we go. Okay, that's weird. Move on. Okay, same thing here. The first number tells us to go to the right. The second number tells us to go up. So if people miss these, they did them backwards. I'm going to go to 17 because those were all graphing points. Now, the one you guys all did not like. Deborah wants to decorate her patio with flowers. The graph shows the relationship between the number of clay pots she used and the number of flowers she planted. So when it gives you a graph, try and figure out what it's telling you. So this tells us if she uses 1 clay pot, how many flowers did she plant? 4. If she used 4 clay pots, how many flowers did she plant? 16. Okay, so that's just what that shows. Deborah plants flowers in 5 clay pots. Can we figure out how many flowers that is? 5 clay pots is 20, according to the graph. Does everybody agree with that? Okay, so she planted 20 in clay pots. She also planted 6 flowers in a hanging basket. So she planted 20 in the pots and 6 more in a hanging basket. What's a hanging basket, Elise?
Basically like a basket that hangs on.
Yeah, it's really a potted plant, but it hangs in a basket. Raise your hand if you have seen one of those hanging around your house, usually in the summer, okay? So yeah, so she planted 6 in the clay pots and 6 more in hanging baskets. And it wants to know, how many did she plant in all? What do I do? Carter?
20 plus 6.
Yeah, I do the 20 in the clay pots plus the 6 extra is 26 total. Raise your hand if you way overthought that one.
I got 26, but it kind of me wrong. Yeah, same.
Did I give you a +1 at the bottom?
No.
Okay, I'll look at it. Okay, next one. Now that I made that one make sense, let's look at the next one and see if you can figure out what the correct answer is. So on a cold day, Trisha and her friends go out for ramen, a Japanese noodle soup. First they order appetizers, then they order ramen. The graph shows the relationship between the cost of their ramen and the total cost of their meal. The group's ramen cost $50. Trisha and her friends decide to split the total cost of their meal evenly among the 5 of them. How much does each person pay? What do we do here? Aiden?
We do 50 minus 5, and you go to 60 minus.
Nope. This one's trickier than the other one. Kinley, what do you think?
If the ramen costs $50, then you go to 50, then you go up to total cost of ramen, and then up there it's 60. So that.
Okay, so pause. So if they give us a graph with data, do you think we are going to have to use something in our problem from the graph? Yeah. So they tell us the group's ramen costs $50. So that should make my eyes go up here. So cost $50. Cost of ramen is $50. So my eyes should have went right there. And then we would have looked over here and said, okay, this is the total cost of the meal. So just their soup costs $50, but their total meal costs $60. Okay, Kinley, unpause.
And then if there's
Split evenly means what kind of math? Divide. So then we would have had to take 60 divided by 5, which is $12. Okay, and again, I agree those are tricky, but are they as tricky as you made them on Friday? No, it's just they're multi-step and you weren't expecting that. Okay, any questions over the quiz? No questions at all? Okay, set it aside. Pull out your weekly worksheet if you don't already have it out. See if I can get this to load. There were some on the weekly worksheet that I wrote example next to. So let's just kind of examine our weekly worksheet. This one is a little bit longer, okay, than typical weekly worksheets, but we're going to do some together right now, and you don't have any other math homework tonight besides work on your weekly worksheet, okay? Typically you have other math homework in addition to this, so tonight on the homework board, I'm just putting weekly worksheet, okay? And dino division if it's not done. My suggestion to make it your life a little bit easier is try and get the whole front side done tonight, okay? Since that's the only math you have, and that'll put you on a good track to get it done pretty easily by Friday. So number one, do we know how to multiply multi-digit numbers?
Yes.
Yep. We know a couple different ways. Do I care how you get there? Nope. Number two, same type of problem, multiplication. Number three, now here's one where they don't give us a ton of room. So if you would like, it might make it easier to work the problem this direction, to like set it up to where you have a longer way to set it up. What are we going to have to do before we work out that problem? Hutley? Yeah, make your list of 12s might be beneficial. Same thing on the next one. It's the divisor is 15, which is a larger divisor, so you might want to set it up and write your multiples. And again, if you want to turn your paper sideways to work that one, that's fine. Okay, the next one, these are the ones I wanted to talk about. So adding and subtracting decimals. Okay, did you guys touch on that last year at all?
Yeah.
Okay, but I think they kept them pretty simple like these ones. Does anybody know the rule for adding and subtracting decimals? We're going to go over it and add a lot to it this year, but the basic rule for adding and subtracting decimals, anybody know it? They've already done it for us in these problems. That's why I felt okay to give you these problems, even though we haven't learned it this year. It's just line up the decimal points. Line up the decimal points in a nice straight line through the problem all the way down to the answer. So if you look here, when you're adding and subtracting decimals, our decimal point should be in a straight line all the way down to our answer. And then you just add or subtract normal. So here they took 6 plus 0 and got 6. 6 plus 4 was 10. There's their 0. They regrouped. The decimal point's already there. We put in the decimal point before we do any of the math. And then 1 plus 2 plus 1 is 4. 2 plus nothing is 2. Okay, let's go ahead and do the next one together. They already lined them up for us. They did the hard part for us, so we're going to put our decimal point down in the answer. Now we just have to add like normal. What is 8 plus 5? Addie? 13, so I put a 3. I regroup. Aubrey, what's 1 plus 9 plus 1? 11, so I put a 1. I regroup. Fisher, what's 1 plus 6 plus 2? 9. And then 4 plus nothing is 4. So 49 and 13/100ths would be the proper way to say that. Let's go over to subtraction. It's the exact same thing. Line up the decimal points from the problem all the way down to the answer. So the first thing we'll do is go put our decimal point down here. Now we subtract like normal. Can I take 2 minus 4? Nope, so we have to regroup. That's going to become a 1. This is now a 12. What's 12 minus 4, Aiden?
12 minus 4 is 8.
8, okay. Can I do 1 minus 5? Nope. Lexi, what do I do?
You have to regroup.
Yep, I have to regroup from the 9. That's an 8. That's now an 11. 11 minus 5, Ava, is 6. 8 minus 7, Hutley? 1. 2 minus 2? 0, so we don't have to put anything. Okay, is adding and subtracting decimals hard? Nope. Well, I just had to refresh your memory on that. Let's go down here because it's been a while. Our example is done for us. When you guys did them in class, remember we wrote them on top of each other? And then we circled the digit that gave us our answer. We would go through. Where do we start when we're comparing? On the left or on the right? The biggest digits or the smallest digits? The biggest. So we would look here. 6 and 6 are the same, so they don't tell us anything. 2 and 2 are the same, so they don't tell us anything. The next one, we have 9 and 0. They are different. Which one is bigger? The 9. So we would say that that one is larger. Okay, it's just been a while since we've done those, so I wanted to, get those wheels turning again. On the next set, I just want to point out, this side is all multiplication. This side is all division. Do we work multiply and divide the same way? No. Nope. Okay. Does anybody have questions over those kind? No? Okay. We are going to do one of these together. I don't care which one. Wyatt, which one you want to do together? One on the left or one on the right? The one on the left? Okay. Notice, how did I already set those up to make our life a little bit easier? Emma? Yeah, I lined up the decimal points. So when you guys do the one on the right, I suggest you line up your decimal points to make them comparable. Then we have to look. We're doing greatest to least. So let's go through. We start on the left. They're all 5. So does that help me? Nope, the 5s don't help me. 6? Nope, because they're all 56. Now the next column, I just want you to put like an arrow right there. I have 0, 1, 0. What does that column tell me? Elise?
That the middle one is the least.
Yeah, not the least. It's the greatest because 1 is bigger than 0. So this one right here is my biggest. Now here's where I goofed up. I said greatest to least, and then what did I write down here?
Least.
So let's mark that out and write greatest to least. And I think it's the same on the other one. Yep. Greatest to least. So let's go ahead and fix that here too. So we will write that one first, 56.10. Okay, and then I'm going to mark it out so I know I'm already done with that one. Then I would go to the next column. What do you notice about my 2 numbers left in the next column? Hutley?
They're each 1.
Yeah, they're both 1. So do those ones help me? Nope. So I'm going to just mark off that column so we know it doesn't help. Now, the bottom one has a number. The top doesn't have a number that I can see. What number is up there, Carter? 0. Remember, I can add as many zeros to the right of the decimal point as I need to in order to compare. Now, can I tell which one is larger? Which one's larger, Hutley? The bottom one. So let's see, was that a 1156.011? And then the last one, we just write it as 56.01. Why do you think I write it like that and not 010? Elise?
Because the last 0 is really rare.
Oh, yeah, it wasn't part of the problem, okay? I can put as many there as I need to get my answer, but it's not part of the problem. Okay, flip that paper to the back. I think the back you guys should be pretty good on. You can mark off, actually, 2 of them that I meant to delete before I printed it. You can mark off this one. Oh, wait, not that one. Never mind, that's rounding. Never mind, we should know how to do that. But I showed you an example to show you what I want in that first line. Round it and then give the rounded answer. The estimate is the rounded answer. Okay, questions over any of that? Okay, so your homework tonight is just work on your weekly worksheet.